Hi, everyone. So this one's going to be a bit of a doozy. I kind of did this to myself on purpose. So if you're watching this, I succeeded. The four books I'll be talking about today are A New Concept of the Universe by Walter Russell, The Self-Evolving Cosmos by Stephen M. Rosen, Order Out of Chaos by Isabel Stengers, Amelia Prigozhin, and The Allure of Machinic Life by John Johnston. So let's get started. So first up is A New Concept of the Universe by Walter Russell. Oh boy. For those who haven't heard of this close friend of Nikola Tesla's, he has quite a story, not least of them a 39-day illumination experience from May to June of 1921, the results for which Tesla is said to have told him to bury your findings until humanity is ready. I'd put this vision of an oscillating universe in a similar category to that of The Animate and Inanimate by William James Sidis, The Eternal Return by Donald Eaton Carr, which is a bit tough to find, this being a photo of my own copy of the book, or of course the Hindu Vedas. In any case, I suspect that his astuteness is in a bit of an if you know category, which isn't to say that A New Concept of the Universe is written with a precise method of demonstration as a rigorous philosophical text, despite some subtle resonances with other thinkers implied by his cosmogony. For example, his conception of love as precisely constitutive of natural processes does echo Charles Sanders Peirce in Evolutionary Love and Elsewhere, and his rallying cry against putting too much emphasis on effects without pursuing their unseen causes echoes Deleuze's use of transcendental deduction, indifference, and repetition. However, this particular book is written in a series of oracular and at times koan-like statements with subject headings taking aim at specific findings of the science of the day. For those familiar with the practice of reading hermetic or mystical texts, perhaps in search of the evocative, I would perhaps read him like that. To wit, the idea of the silent harp string note eternally exists. Electrical division into sound manifests the idea, but the idea belongs to silence, and to silence it returns, for reborning again as a simulation of idea. As to his purpose, however, he writes that it would be in order that the physicist of tomorrow can know and comprehend the universe as one whole, instead of sensing it as many separate parts, which he will never be able to fit together. One important note in relating this text is that when Russell refers to light with a capital L, which he does extensively, he doesn't mean incandescence. He writes that incandescence simulates light in the cinema universe of macrocosmic make-believe, but incandescence is not light. It is but motion. Incandescence is merely the compressed half of the one divided pair of opposite conditions which constitutes matter and space. In other words, light is a stillness which centers motion and is described elsewhere as magnetic. All motion, by contrast, is electric. Not too controversial, although we might more than speculate that his emphasis on characterizing a universal mind could help us map these concepts onto our local mind and its attractor landscapes, its physical substrates, and the puzzling questions it compels us to ask if we focus too much on the electric. That's all I'll say about that. This was certainly the toughest text to figure out what to say about it. So on to the next book. So let's talk about The Self-Evolving Cosmos by Stephen M. Rosen. I found this book while exploring things adjacent to George Spencer Brown of Laws of Form fame, whereby I discovered that the knot theorist Louis Kaufman seems to have an ongoing interest in unusual byways, and I noticed that he'd edited this one. As such, it's not an oracular text like the last one, but does explore a bit of a subtle subject, namely the intractable entanglement between subject and object that has haunted physics for the last century. He shares something of this perspective of Peter Woit, author of Not Even Wrong, that string theory seems to be missing something on the path to unification, but also that there is something of a conceptual impasse as well. To untangle this, Rosen digs back into the conceptual history, such as Kaluza-Klein theory, but he also goes much deeper than this, calling into question the compulsion of physics to search for any sort of primordial perfect symmetry. About this, he writes, in developing a new intuition of space, we cannot put symmetry first by speaking of symmetry breaking, but must view symmetry itself as arising from a primordial pre-symmetric condition, admitting that it is not only contemporary physics that privileges symmetry, physics has always done so. What we found in the opening chapters of this book is that physicists from the outset have been looking to subdue the inhomogeneous, chaotic element of nature as part of their ongoing quest for individuation. We considered this basic non-symmetric feature under its ancient name, the Apeiron. It would not be too much to say that this chaosmic Apeiron is indeed the driving force of Rosen's exploration, here and in another of his books, Dimensions of Apeiron. In addition, he appeals to the phenomenology of Merleau-Ponty, particularly his concept of depth, which he relates to what Heidegger calls time's three ecstasies of past, present, and future. About depth, he summarizes that it is, one, the first dimension, inasmuch as it is the source of the Cartesian dimensions, which are idealizations of it, It is 2, a self-containing dimension, not merely a container for contents that are taken as separate from it. And it is 3, a dimension that blends subject and object concretely rather than serving as a static staging platform for the objectifications of a detached subject. The move here is from what he calls object in space before subject, of which string theory is seen as a last-ditch effort, to a concrete transpermeation of object, space, and subject. I picked this text up for the first time in a while, and it gets pretty far into the weeds, so this can only be a shallow sketch. The pages I just read were looking at the Einstein-Minkowski diagram and how it sets up a clear-cut dichotomy between events that are successive and those that are contemporaneous. Namely that all events within the future cone are definitely after the here and now, and all events in the past cone are definitely before it, since one would have to travel faster than light in order to view events within those cones contemporaneously. The problem is, of course, that our perspective doesn't exist as an idealized point, but draws a contemporaneous present out of many points, arbitrarily many points. In other words, the here and now has a thickness to it belied by this idealization. Rosen writes about how our embodied nature irremediably mucks up a clean separation between subject and object. That's all I'll say about that. I've left out the topological themes that make this book a volume in Kaufman's series on knots and everything, but that's why it's there and why I found it. I can't believe I chose these 4 books for a single run. Anyway, on to Order Out of Chaos. So Order Out of Chaos is a summary of historical and philosophical context for Ilya Prigozhin's Nobel Prize-winning work on dissipative structures, a class of open system characterized by spontaneous symmetry breaking and self-organization. The simple case they describe is the logistic equation, which describes the evolution of a population. For population N, it looks like this, where R and M are birth and death constants, and K is the carrying capacity of the environment. It will eventually reach a steady state where the population is equal to the carrying capacity minus the ratio of deaths and births. Writing a discrete logistic equation written in this form, where T and T plus 1 are separated by a 1-year interval and the death term is left out, will produce many solutions. As birth rate R is shifted up and down, it switches from equilibrium to periodic behavior to chaos, but chaos never happens in nature. So they ask why, noting that carrying capacity, birth, and death rates all vary during ecological evolution, so that equilibrium is only temporary, and logistical niches will consist in a succession of species with the greatest quantity of K minus M over R. They mention how nature's strategies of various poisons and spines are never as effective as remaining undetected, an ideal approach by some caterpillars. They note that while this same equation is often used to describe technical breakthroughs as well, such as the effect of steamships on sailing ships, where carrying capacity, or K in this case, is the demand for sea transport, many innovations create their own niches in a kind of self-accelerating evolutionary feedback loop, wherein the carrying capacity K of a system is a function of the way in which the ecology is exploited. The next section explored reproduction rate, or R strategies, and carrying capacity, or K strategies, noting that we come to problems where methodology cannot be separated from the question of the nature of the object investigated. We cannot ask the same questions about a population of flies that reproduce and die by millions without apparently learning from or enlarging their experience, and about a population of primates where each individual is an entanglement of its own experiences and the traditions of the populations in which he lives. On the latter, they take a quote from Levi-Strauss, contrasting statistical and mechanical ways of looking at society, anthropological versus sociological accounts, swarm behavior versus hierarchical behavior, and the trickiness of quantitative versus qualitative growth in prescriptive modeling. At the risk of not doing any of these themes enough justice, it's already time to move on to the next book. So let's talk about The Allure of Machinic Life by John Johnston. This book defies easy summary, but it's essentially a conceptual history of cybernetics, chaos science, complex adaptive systems, and artificial life fused with Deleuze-Guattarian themes. In this respect, it's actually very similar in outlook to The Cybernetic Brain, Sketches of Another Future by Andrew Pickering, whose paper Cybernetics as Nomad Science inspired my hope that there might be a comprehensive way out of the algorithmic passivity and techno-scientific hegemony of the age, namely through a constructivist practice of this strange thing called nomad science. Incidentally, I also have my eyes on Pickering's paper Beyond Design, Cybernetics, Biological Computers, and Hylozoism, which might be a nice introduction to Stafford Beer, who I'll be talking about next time. Anyway, the portion I read describes the exploits of the Dynamical Systems Collective, also known as the Santa Cruz Chaos Cabal, a story told by James Gleick in the book Chaos Making a New Science. It focuses particularly on the work of Robert Shaw, whose combining of information theory with dynamical systems theory and the study of chaotic or complex systems, he writes, marks a conceptual accomplishment of great import, noting that it was Shaw's article, Strange Attractors, Chaotic Behavior and Information Flow, published in 1981, that first makes the case for information theory. Indeed, Shaw shows how chaotic attractors can be seen in a new light as generators of information. As to where the information comes from, Johnston writes that the uncertainties of the microscale, the bath of microscopic or randomness in which anything physical is immersed, as Shaw vividly puts it, are being systematically pulled up to macroscopic expression, and that, as Shaw concludes, that new information is continuously being injected into the macroscopic degrees of freedom of the world by every puff of wind and swirl of water, an effect that may put severe limits on our predictive ability, but also ensures the constant variety and richness of our experience. So Johnston briefly summarizes Claude Shannon's theory of information, originating in his watershed paper, A Mathematical Theory of Communication from 1948. He writes that the theory takes into account the entire process of encoding a message in a signal or medium, transmitting it through a channel impeded by noise, and decoding the message at the receiver's end. Because noise in a communication system causes uncertainty as to how closely the message received compares with the message sent, the theory requires a precise measure of this uncertainty. A concept that makes this uncertainty quantitative and measurable lies therefore at the heart of Shannon's theory. This concept is information. Shannon borrows Boltzmann's equation for entropy in a closed system, explaining that P sub I, in this case, is the probability of a single symbol's occurrence. The probability of an entire message can be found by adding up the probabilities of the individual symbols that compose it, where K is the choice of measurement unit. This basic concept might be familiar to anyone interested in encryption, compression algorithms, data science, or computer science more generally, but what's important to the discussion of what Shaw brings to the picture in his 1984 book, The Dripping Faucet as a Model Chaotic System, relates to the evolution of this channel's dynamics, which is to say that instead of analyzing the distribution X versus distribution Y traveling over a channel from transmitter to receiver, he iterates these mappings over time, analyzes them as the past moving over this channel into the future, which enables Shaw to measure quantitatively the changes in the system's predictability over time, which is his primary objective. Shaw writes that an unchanging and completely known variable communicates no information into the future, although a static structure is certainly a predictable element, establishing continuity through time. It becomes part of the fixed time-independent system description. The information measures described here are a property of the system's dynamics. In mechanics, as in the human sphere, the transmission of information requires the possibility of change. I think I'll stop there, though I've barely done any justice to these ideas, either on a technical or conceptual level. Although I have a feeling that these ideas will pop up again in different contexts. If this brief gloss sounded interesting, I do wholeheartedly recommend this book. So that just about wraps it up. I'm glad I attempted this, but I'm also glad I chose an easier set of books for the next video. If you enjoy what you saw, please like and subscribe, and feel free to leave any comments in the comments section. Thanks.